3.1 is on linear functions. So first we need a definition of a linear function, and it's an equation that makes a straight line when graphed. Right, and in looking at the equation, I know that it's going to make a straight line if the degree, which means the highest exponent, is 1. So an example would be like y equals 2x plus 4. Right, just like if we have just an x and we know that there's no number in front, we can assume that it's a 1. It's just not written. Same thing with exponents. So if there's no exponent written, we can assume that it is a 1. So then the highest exponent in this equation would be 1, which means that it is a linear function. Let's look at some things that would be non-examples or would not be linear. So if I have an exponent higher than 1, so y equals x squared, that is not linear. We can't have division by a variable. So y equals 2 over x, that's not linear either. Even though this would have an exponent of 1, when we have a variable in the bottom or variable in the denominator, it's not linear. The other thing that we can't have is a product of x and y. So if I have y equals xy plus 7, this makes it not linear. We can't do that. All right, so if you ever have x and y multiplied together, that would not be linear. So here we have some example problems. They want to know, is it a linear function? Well, we have y squared right here, so that's a no. Can't have any exponent higher than 1. If I look at this one, 8 plus y equals 4x, that meets all my criteria. The highest exponent is 1. I don't have any division by variables or anything crazy like that, so yes, this is a linear function. We have 9xy minus 6x equals 7. Well, there we cannot have x times y, so this one, no, it's not a linear function. All right, why don't you go ahead and pause here and try the next 3. Should be no, yes, yes. We have squared here, that makes it no. Here, even though we have 2 y's over here, that's okay because these are like terms, right? And they both have an exponent of 1. We could put them together and make this 12x equals 7 minus 10 would be negative 3y, and that's linear. Same thing here. We have 2 x's, but they both have an exponent of 1, so they meet our definition for a linear function. So when we have linear functions, we have what's called an x and y-intercept. And the x-intercept is just wherever the graph crosses the x-axis. So remember from before, the x-axis is the horizontal axis right here. So wherever this line crosses the x-axis, right there is my x-intercept. And so then the y is just wherever the line crosses the y-axis, so the vertical axis, so right there would be my y-intercept. And when we write x and y-intercepts, they are points. They're actual points on the graph, so right here where that touches the y-axis. So we need to write them as ordered pairs. So my x-intercept is at negative 2, 0 right there. And then my y-intercept is at 0, 1. And what I want you to notice is when we have an x-intercept, okay, the y-coordinate is 0. That is always true because if I'm on the x-axis, I'm on this line, I haven't moved up or down from the origin at all. So for the x-intercept, the y-coordinate will always be 0. And then the reverse is true for the y-intercept. The x-coordinate will always be 0 because we're just moving up and down the y-axis and not left and right at all. So it's backwards, you got to remember. For the x-intercept, y is 0. For the y-intercept, x is 0. So here we have 2 more examples that we're just going to look from the graph. So find the x and y-intercepts. Well, the x-intercept is on the x-axis right there at 20. And the y-intercept way up here is at 30. So I need x-intercept of 20, y-intercept of 30. That would be choice B. All right. Same thing here. Now, this has a y-intercept right here of 150. That's where it crosses the y-axis. But does this line ever touch the x-axis down here? It's going straight across horizontally. It's never going to come down and actually touch the x-axis. So we have a y-intercept of 150, but no x-intercept. We're going to use intercepts for graphing, because if I have my x-intercept and my y-intercept, that gives me 2 points on the graph, and then I can just draw a line between them. So to find the x-intercept, I'm going to set y equal to 0, because for my x-intercept, the y-coordinate is 0. So I'm going to take the original equation and I'm going to substitute 0 in for y. And when I go to solve this, 4 times 0 is 0. So that plus 0 would cancel everything out, and I just have 2 left over here. And then to solve this, I'm going to need to divide by 2. And I'll divide by 2 on both sides. And when I do that, I get x equals 2. So that means that my x-intercept is at 2, 0. Then to find the y-intercept, I'm going to do the opposite. I'm going to set x equal to 0. So I'm substituting 0 in for x. 2 times 0 is 0. So all I'm left with over here is 4y. Then to solve for y, I'm going to have to divide both sides by 4. When I do that, I get y is equal to 1. So that means I have a y-intercept of 0, 1. And then I'm going to graph both of these points. So I'm going to put a dot at 2, 0. There's my x-intercept. And then I'm going to put a dot at 0, 1. That is my y-intercept. And then I can just draw a line between those two dots. And it goes forever in both directions. And now I have graphed this equation. Here we have another example. We're going to do the same thing. We're going to find both intercepts and then use them to graph. So I have negative x plus 2y equals 3. To find my x-intercept, I'm going to set y equal to 0. So I plug 0 in for y. 2 times 0 is just 0. So I have negative x is equal to 3. To get rid of this negative, remember it's not written, but we know that there is a 1 right here. So this is negative 1x. So I'm going to divide both sides by negative 1. And I get x is equal to negative 3, so that means my x-intercept is at negative 3, 0. So I'm going to go ahead and plot that point, negative 1, negative 2, negative 3, right there. All right, then we have to find the y-intercept. So to do that, I need to plug 0 in for x. Negative 0 is still 0, so I'm left with 2y is equal to 3. And to get y by itself, I have to divide both sides by 2. So my y-intercept is 0, 3 halves, okay, and it's okay that it's a fraction or not a whole number. I can still graph it. I know that 3 halves as a decimal would be 1.5, so on the y-axis I'm going to go up 1.5, so it would be right about there. And then I'm going to draw a line between these 2 points. It goes on forever in both directions, so now I have graphed that. Now, I'm drawing this line with my mouse, so it's not very straight. You're going to get a straight edge and draw a perfectly straight line on everything that you turn into me. I want you to go ahead and try this second example, so pause the video here, try this on your own, and then we will talk about the answer in class. So that was graphing using the intercepts. We can also graph by making a table. So what I'm going to do is I'm going to pick some x values and I'm going to plug them into my equation here and simplify so that I get some y values, and then I'll be able to graph those ordered pairs. So here's our equation, y equals 1/3 x plus 2. I'm going to give you a little helpful hint. You can pick whatever numbers you want for x. It doesn't matter. Usually we want you to pick some negative numbers. 0 is always a good spot to try because then that gives you your x-intercept, and then pick some positive numbers. So negative numbers, 0, positive numbers. Whenever you have a fraction here, to make the math easy for you, pick numbers, okay, that can be divided by whatever's on the bottom here. So the numbers I'm going to pick, I want them to be able to be divided evenly by 3. So here's what we're going to pick for our table. I'm going to put in negative 6, negative 3, because they can both be divided by 3. Then we're always going to pick 0. And then I'm also going to put in positive 3 and positive 6, because they can be divided by 3, and it makes my math easy. So what we're going to do is take each of these x values and plug them into the equation and then simplify. So the first one is negative 6. So if I plug negative 6 in place of x, I'm going to multiply 1/3 times negative 6, and that gives me negative 2. You can use your calculator, use the fraction button, but we also talked about how anytime it's 1 over something, multiplying by this is the same as dividing by the bottom number. So negative 6 divided by 3 is negative 2. So I have negative 2 plus 2, and that gets me y equals 0. So when x is negative 6, y is 0. Then we're going to do the same thing for all of these x values. So I'm going to take negative 3 and plug it in for x, 0 and plug it in for x. So just like we did here, but with these numbers in place of x. So why don't you pause now and go ahead and do these next 4 numbers on your own. Alright, so hopefully you were able to plug in these numbers and get 1, 2, 3, and 4 as your y values. So then what I did is I graphed each of these ordered pairs. So I put a dot at negative 6, 0. This is negative 5, so I just extended my graph a little bit. Negative 3, 1, 0, 2, 3, 3, and then 6, 4. So I put a dot for each of these ordered pairs and then just connected them all in a straight line, and I graphed that. So now we have a second equation, y equals 2x minus 2, and we're going to fill in the table and then graph it. Since this time we don't have a fraction here, it doesn't really matter what numbers I pick. What you're going to see over and over again is these 5 numbers, so negative 2, negative 1, 0, 1, 2. It's not like a rule that you have to pick those or anything, but generally those are values that are just picked because it gives you negative numbers, positive numbers, 0. So I would just stick with those. So we're going to do the same thing here. You're going to take these numbers, substitute them in for x, and then get the y values. And you're going to do this all on your own, so pause and finish this problem. All right, we'll look at that last example in class, go over it, make sure you're doing it right. I want to look at this one, though, is kind of a special case. It says y equals 3. There's no x anywhere in there, so how am I supposed to plug in x values? We don't have to. All right, if y is equal to 3, then it means no matter what x is, y is always going to be 3. So these are all going to be 3's no matter what, always 3's. All right, so when I go to graph it, let's see what that looks like. So I have negative 2, 3, negative 2, 1, 2, 3, negative 1, 3, 0, 3, 1, 3, and 2, 3. So it's always going to be equal to 3, and that's going to give me a straight across horizontal line. And it's really hard to draw straight lines with a mouse, by the way. So this is a special case. All right, y equals 3 is a straight across vertical line. What if I changed it and made it x is equal to 3? All right, then what would my table look like? Well, all of the x values would have to be 3 no matter what. And then I would get to pick whatever I wanted for the y values. So it's kind of the opposite of this one. And what happens when I graph that? Well, I have all my x values are 3. So 1, 2, 3, negative 2. Let me do this one in a different color. All right, so I'll graph this in red. 3, negative 2, 3, negative 1, 3, 0, 3, 1, 3, 2. So when I have x equals some number, I have a straight up and down vertical line. And we'll talk a lot more about these special cases, but when you go to make your tables, if it says y equals 3, it means the y values are all 3 no matter what we put over here, and vice versa for the x values. So in your notes you have 2 more examples on this page, and then the examples continue for a while on the next page. What I want you to do is just finish this page. So just do number 1 and number 2, fill in the table and draw the graph, and then we will do a bunch of these in class.